Welcome to ISPFL9, Management and Analytics. Module 2, Data Analytics and Workflow. Preparation phase. Before you analyze your data, you must acquire the data and reformat it into a manner that is suitable for computation. You can acquire data from the following sources. Data files from online repositories such as the public websites. Data files streamed on demand through APIs. Physical apparatus such as scientific lab equipment that has been attached to computers. Data from computer software such as log files from the web server. Manually entering the data in spreadsheet files. Next, we have analysis phase. At the core of any analytics activity is analysis. This involves writing computer programs or scripts that analyze the data to derive helpful insights from it. You can use programming languages such as Python, Perl, MATLAB, R, or Hadoop. Third, we have reflection phase. At this stage, you'll frequently be alternating between the analysis and the reflection stages as you work on your data to obtain the necessary information. While the analysis phase is a purely programming process, the reflection phase requires critical thinking and communication with your clients about the outputs obtained. After inspecting your set of output files, you can take notes of your dealing with an experiment that's either physical or digital format. Dissemination phase. Dissemination is the final phase of data analysis workflow. You can present your results using written reports, such as the internal memos, PowerPoint presentations, or business white papers. If you're in the academic field, you can publish the academic paper. What are the different characteristics of data analysis? First, we have programmatic. There might be a need to write a program for data analysis by using code to manipulate or do any kind of exploration because of the scale of the data. We have data-driven. A lot of data scientists depend on a hypothesis-driven approach to data analysis. For appropriate data analysis, one can also avail the data to foster analysis. This can be of significant advantage when there is a large amount of data. For example, machine learning approaches can be used in place of hypothetical analysis. Next, we have attributes usage. For proper and accurate analysis of data, it can use a lot of attributes. In the past, analysts dealt with hundreds of attributes or characteristics of the data source. With big data, there are now thousands of attributes and millions of observations. Iterative. As whole data is being broken into samples and samples are then analyzed, therefore data analytics can be iterative in nature. Better compute power enables iteration of the models until data analysts are satisfied. This has led to the development of new applications designed for addressing analysis requirements and time frames. Process components. So first we have the purpose, questions, data collection, data analysis, interpretation, writing, reporting, and dissemination, and the last one is the evaluation. We're going to tackle each of these process components one by one. So first, we have the process components number 1. So what do we do and why? So in short, what's the purpose? An effective data analysis process is based upon the nature and mission of the organization as well as upon the skills of the team that is charged with the task of collecting and using data for program purposes. Above all, an effective data analysis process is functional. That is, it is useful and adds value to the organizational services and individual practices. In some cases, the data analysis process can even be regarded as fun. As you know, the Head Start Program Performance Standards, or HPPS, are the basic framework for program operations. In addition, Head Start program operations are guided by other federal and state regulations, local licensing requirements, community factors, and the goals or mission of the agency. Therefore, a preliminary step in the data analysis process is to select and train a team to carry out the process. Because the HSPPS present minimum standards for program services and provide guidance for the implementation of the various content areas, a process for data collection and analysis should be consistent with this and other regulations. More specifically, the standards are the basis for the first step in the data analysis process, forming one or more specific questions to be examined. Process components number 2, so what do we want to know? Before effective data collection or analytical procedures can proceed, one or more specific questions should be formulated. These questions serve as the basis for an organized approach to making decisions. First, about what to collect. Second, about which types of analysis to use with the data. Some questions are close-ended and therefore relatively straightforward. For example, did our program meet the 10% mandate for serving children with disabilities last year? Other questions are highly open-ended, such as, how could we do a better job of parent involvement? In the first case, there are only two possible answers to the questions. It's either yes or no. In the second case, a possible answer to the question could include many relevant pieces of information. Many real-life questions that program staff face in the course of their work fall somewhere in between these two different extremes. Different types of questions require different types of data, which makes a difference in collecting data. In any case, the selection of one or more specific question allows the process of data collection and analysis to proceed. Based on the nature and scope of the questions, that is, what is included in the question, programs can then create a plan to manage and organize the next step in the process, that is, referring to data collection. Finally, by formulating specific questions at the beginning of the process, programs are also in a position to develop skills in evaluating their data analysis process in the future. We have process components number 3. So what information can help us answer our questions? Data collection is a process in and of itself, in addition to being a part of the larger whole. Data come in many different types and can be collected from a variety of sources. So these are the following sources. It could be in a form of observations, questionnaires, interviews, documents, tests, and others. The value of carefully selecting the questions to be examined is therefore of major importance. The way that the question is worded is the foundation for an effective data collection plan. We urge programs to develop a specific planning process for data collection, no matter how brief, in order to avoid the common pitfall of the collection process, which include the following. Too little data to answer the question. Next, we have more data that is necessary to answer the question, and data that is not relevant to answering the question. So in order to successfully manage the data collection process, programs need a plan that addresses the following. What types of data are most appropriate to answer the questions? How much data are necessary? Who will do the collection? When and where will the data be collected? And how will the data be compiled and later stored? By creating a data collection plan, programs can proceed to the next step of the overall process. In addition, once a particular round of data analysis is completed, a program can then step back and reflect upon the components of the data collection plan and identify lessons learned to inform the next round. Process components number 4. What are our results? Once data have been collected, the next step is to look at and to identify what is going on. In other words, to analyze the data. Here, we refer to data analysis in a more narrow sense. as a set of procedures or methods that can be applied to data that has been collected in order to obtain one or more sets of results. A list of specific analytical procedures and methods is provided because there are different types of data. The analysis of data can proceed on different levels. The wording of the questions, in combination with the actual data collected, have an influence on which procedures can be used and to what effects. The task of matching one or more analytical procedures or methods with the collected data often involves considerable thought and reflection. As a GAO report puts it, balancing the analytic alternatives calls for the exercise of considerable judgment. This is a rather elegant way of saying that there are no simple answers on many occasions. Process components number 5. What do the results mean? Once a set of results has been obtained from the data, we can then turn to the interpretation of the results. In some cases, the results of the data analysis speak for themselves. So for example, if a program's teaching staff all have bachelor's degrees, the program can report that 100% of their teachers are credentialed. In this case, the results and the interpretation of the data are almost identical. However, there are many other cases in which the results of the data analysis and the interpretation of those results are not identical. So for example, if a program reports that 30% of its teaching staff has an AA degree, the interpretation of this result is not so clear-cut. In this case, interpretation of the data involves two parts. First, presenting the results of the analysis, and second is providing the additional information that will allow others to understand the meaning of the results. In other words, we are placing the results in a context of relevant information. Obviously, interpretation involves both decision-making and the use of good judgment. We use the term results to refer to any information obtained from using analysis procedures. We use the term findings to refer to results which will be agreed upon by the data analysis team as best representing the work. In other words, the team may generate a large number of results, but a smaller number of findings will be written up, reported, and disseminated. On a final note, it is important to state that two observers may legitimately make different interpretations of the same set of data and its results. While there is no easy answer to this issue, the best approach seems to be anticipated that disagreements can do occur in the data analysis process. As programs develop their skills in data analysis, they are encouraged to create a process that can accomplish dual goals. First, to obtain a variety of perspectives on how to interpret a given set of data or results, and to develop procedures or methods to resolve disputes or disagreements over interpretation. Process components number 6. What do we have to say? How do we tell the story of our data? Once data have been analyzed and an interpretation has been developed, programs face the next level task of deciding how to write, report, and or disseminate the findings. While it is not the purpose of this information to provide guidance on writing and reporting, we can offer several basic suggestions. So first, good writing is structured to provide information in a logical sequence. In turn, good writers are strategic. They use a variety of strategies to structure the writing. One strategy is to have the purpose for the written work to be clearly and explicitly laid out. This helps to frame the presentation and development of the structure of the writing. Second, good writing takes its audience into account. Therefore, good writers often specify who their audience is in order to shape the writing. A final thought is to look upon the writing or reporting tasks as opportunities to tell the story of the data you have collected, analyzed, and interpreted. From this perspective, the writing is intended to inform others of what the data analysis team would like to provide or discover. Process components number 7. What did we learn about our data analysis process? The final step of the data analysis process is evaluation. Here, we do not refer to conducting a program evaluation, but rather an evaluation of the preceding steps of the data analysis process. In sum, data analysis is a process, a series of connected activities designed to obtain meaningful information from data that have been collected. As the graphics demonstrate, the process can be conceptualized in different ways. Either we can make use of linear or cyclical presentation. However, we strongly believe that either approach can be effective if each of the individual components of the process are included. In turn, each part of the process is based on decision making. Each stage of the process includes decision making, which decisions are made will then influence the remaining stages of the process. So business intelligence tools for analytical reports. Although from the previous discussions that we have, I have already presented some of the tools, let me continue some of the examples for our analytical reports. So while picking the best business intelligence tools for analytical reports, it is imperative to consider choosing tools and applications that would benefit your customers, employees, and all departments concerned with analytics. When you have a great tool, you will have the attention of your customers. The employees will also be actively interested to venture further and come up with interesting insights. Software and tools that have great interactive interface and outputs that are aesthetically pleasing will evoke the interest of the viewer. Enterprises have a massive reservoir of data at their fingertips. The task is to filter the relevant information and project an analysis over a given time frame. Here are some of the most preferred business analytics tools used for business analysis. So first, we have Tableau. Tableau provides reports that are creative and that use attractive design templates and animations, resulting in outputs that are visually appealing and easily palatable upon a single glance. Users can either use the service online or through their Tableau platform service. Tableau has a wide range of data sources to pick from, and its data visualization seeps into its administrative tools as well. Next, we have Qlik. The tool is famous for its interactive data visualizations and is popular among all contenders in the world of analytics and business intelligence. Depending on your requirements, Qlik offers varied services ranging from simple reports to complex analytics guided platforms to tools that allow external data feeds. Qlik Sense is one of the products that offers self-serve solutions. It is primarily a visualization tool that is intuitive and uses the drag and drop methodology. Hank. One of the services Hank offers self-serve solutions. It generates graphs, charts, dashboards, and data visualizations from Hadoop data lakes. Hank is quite compatible with various platforms and is often preferred over the others for its compelling data visualizations and aesthetically pleasing graphical outputs. Trillium. Data quality is of prime importance, especially when you are a self-serving analytics team and the range of data sources is always on the rise. Instead of dedicating several months just to consolidate and clean up the data, Trillium assures the completion of data analysis with a time span of 30 days. Trillium, a leading BI tool, is popular. It offers two products dedicated to data quality control: Refine and Prepare. Both these products are programmed to sync distinct data sources and pool them all together into a single repository. Refine goes a step further to polish and form a clean dataset. It eliminates conflicting entries and incomplete records. For fascinating data visualizations, the dataset can then be fed into Tableau or ClickView as Trillium partners with both these platforms. Logi Analytics. Logi has now evolved into a data visualization and a self-service analytics platform. Logi provides you with the infrastructure to fully customize the front-end self-service data analysis and visualizations. The effect BI tools have on analysis. These are among the top BI tools that are out in the market. Equally competent ones are being rolled out every day. Business intelligence tools are in great demand, and they solve many issues faced by organizations. The tools are designed to digest massive chunks of data to decipher and provide an impressive, visually appealing, and aesthetically pleasing graphical representation of the trend in a given time frame. The world of innovation and development constantly produces BI tools. The creative streak involved in developing themes for the final output has no limits. With data visualization and aesthetically pleasing graphical representations taking center stage, this is massive scope for innovation and evolution of BI tools. Organizations are making a conscious move away from the software architecture and design to more user-friendly applications. Businesses in the BI market are concentrating on building a better interface with the end users to appeal to the viewers on a larger scale. The best business intelligence tools are out there in the market to help your product showcase a trend that is not just accurate and well thought out, but that also has an aesthetically pleasing element. BI tools are in the limelight as companies release their big data. In tandem, evolutionary firms like Tableau and Click offers powerful self-serve analytics platforms. The world of analytics is looking forward to embracing and partnering with platforms that produce an output that has an inbuilt features to decipher their massive chunks of data and produce graphs that represent the trends and plot the data in an artistic manner as well.